Yes. Yeah, we welcome you back. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. Okay, this question comes saying, define the term ampholite or amphoteric substance. What is it? Ampholite is a substance which acts as a base in one reaction and as an acid in another reaction. Okay, that is that. Then comes this question. It says, the following substances are ampholytes. So these are the substances we have water, bisulfate, hydrogen carbonate, and hydrogen phosphate ions. And it says, explain using an example of each of the above. Okay, yes, we have water. Water is ampholite. How does it come to be? You have to remember, let's give an example here, that if you have water and you add hydrochloric acid, in this case, this is the acid, which is hydrochloric acid, and this is the base. And like I said before, to deal with this equation, you have to use Bronsted Lowry idea. An acid is a proton donor, so the HCl acid will donate a proton to water. Water getting a proton will give you hydronium ion, and the HCl losing a proton, it will give you chloride ions. Okay? So what do we see in this case? We are seeing a case here where this is the acid donating a proton here. So this is accepting a proton, becomes a base. When an acid loses a proton, it becomes a base. So this is the base. And when a base gains a proton, it becomes the acid. We are seeing water here acting as a base. But the same water, if it comes to react with ammonia, it's a different case. In this case, ammonia is basic compared to water. So if it's basic compared to water, it means that water is the acid. And what happens according to Bronsted Lowry idea? An acid is a proton donor. So water will donate a proton to ammonia. Ammonia getting a proton, it becomes ammonium ion. And water losing a proton, it becomes hydroxide ion. So when you come to analyze this equation, what you see? In this case, water is the one which is donated a proton, so is the acid. So ammonia gaining a proton, it becomes the base. When this water, which is an acid, lost a proton, it becomes the base. So this is our base. And when this base gained a proton, it became the acid. So when you analyze this case, what do you see? We are seeing water here acting as a base, and we are seeing the same water here acting as an acid. So this makes water to qualify as ampholite. You have to remember the definition. It acts as a base in one reaction and as an acid in another reaction. Yeah, so we come to hydrogen sulfate or bisulfate ion. So when you have it here, what are you having? It's a bisulfate ion. And it's reacting with what? Let's react it with water in this case. Okay. So, and what do we get? So this species here can act as a base or an acid. What does it mean? It can accept a proton. By accepting a proton, it's the base. Or it can not donate a proton. If it donates a proton, it's the acid. So let us look at the first scenario. Suppose it's donating a proton. A proton to what? Donating a proton to water. So water getting a proton, it becomes hydronium ion. Okay? And a bisulfate losing a proton, it becomes a sulfate ion. Okay? Now, let us analyze. This one is the acid. It donated a proton. This one is the base. It accepted a proton. And when the acid lost a proton, it becomes the base. So this is the base. And when a base gained a proton, it becomes the acid. Okay. Let us look at another scenario here. We have the same bisulfate ion, and it's reacting with water. But in this case, it accepts a proton from water. By accepting a proton from water, it means that the water is the acid, which donates the proton, and the bisulfate is the base. Okay? So what do we get here in under this circumstance? The bisulfate which gained the proton becomes H2SO4. Okay? And the water which lost a proton becomes OH minus. I want you to remind you that this equation must balance in terms of charges. To know that you are right, you have to ensure that they are balancing. If you look at the reactant side, it's negative, and the same applies to the product side, which is also negative. When you go back to our first reaction, what do you see? The side is negative, -1. So when you have to this side, you have -2 plus +1, which is going to be -1, still balancing. So let us come back to this equation. What do we see? This one lost a proton, so it's the acid. This one gained a proton, so it's the base. Now, the one which so when this acid lost a proton, what remains behind is the base. So OH is the base. And when the base gained the proton, it became the acid. So the acid is here. Okay. So back to our bisulfate species. We are seeing here that in this case, hydrogen sulfate was the acid. And this one, hydrogen sulfate, is a base. And what does it say? That one confirms that it is Ampholyte, basing on the definition. So then we come to bicarbonate or hydrogen carbonate ion. Okay? So suppose it's reacting with water. What do we have here? Okay. Let us look at a scenario where the bicarbonate ion is the one donating a proton. Donating a proton to water. So water getting a proton, it becomes hydronium ion. And bicarbonate losing a proton, it becomes a carbonate. Okay. So that is the case. So let us analyze what we have here. It's this one which donated a proton, so it's the acid. And water gained a proton, so it's the base. Now, when an acid loses a proton, it becomes a base. And when water gained a proton, when the base gains a proton, it becomes an acid. Okay? So then we come to another scenario. It's a bicarbonate ion, the same one. reacting with the water. But this time around, it's the water which donates the proton. If that happens, what will happen here? Water donates a proton to bicarbonate, will give you carbonic acid, H2CO3. It's neutral. It's a weak acid. And when this water lost a proton, what remains behind is OH minus. Okay, let us analyze what we have here. Okay, it is water which donated the proton. So water is the acid, according to Bronsted-Lowry idea. And it's this one which gained the proton, so it's the base. Now, when an acid loses a proton, what remains behind is a base. So this is the base. And when a base gains a proton, it becomes the acid. Now, back to analysis. We are looking at our bicarbonate here as an acid in the first case. And in the second case, we are looking at a bicarbonate here as the base. So from the definition, this one suits to become Ampholyte. It is acting as an acid in one occasion and as a base in another situation. Yeah, then we come to hydrogen phosphate or dihydrogen phosphate ion. Let us look at it here. We have H2PO4 minus. And suppose it's reacting with water. What will happen? Okay, suppose in this first scenario, it is the dihydrogen phosphate ion which donates the proton to water. If that happens, what happens? What happens is that water, on gaining a proton, it becomes hydronium ion. And when this one loses a proton, it becomes hydrogen phosphate. That's what we have. Okay. Now we have a second scenario. Suppose we have a second scenario, which is H2PO4 reacting with the same water. Suppose in this case, it's the water which donates the proton. What will happen? What will happen is that we must not forget that this one has a charge 1. What will happen is that on this gaining a proton, it will become phosphoric acid. Okay. Meanwhile, on water losing a proton, it becomes OH minus. Let us analyze the first situation. It is this one which donated a proton, so it's the acid, according to Lowry-Bronsted idea. An acid is a proton donor. And it's this one which gained a proton, so it's a base. A base is a proton acceptor. So when an acid loses a proton, what you form is a base, so this is the base. And when a base gains a proton, it becomes the acid. Okay, let's go to the second case. In the second case, when water lost a proton, it's the acid. And when this one gained a proton, it's the base. Meanwhile, when an acid loses a proton, it becomes a base, so this is the base. And when the base gains a proton, it becomes the acid. Yes. So back to analysis of this question. What do we see? We are having, in this case, it is the acid. And the same species here is the base. Okay. So what does that mean? It means that it qualifies to be called Ampholyte. by the definition. And with that, I would like to say thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. Don't forget to subscribe, to comment, to like, to share. And we need also to remind you that Physical Sciences Silver Bullet is a science YouTube channel dealing with physical sciences grade 12, 11, and 10, and natural sciences grade 8 and 9. We advise you that if you are using the channel, go straight to playlist. Don't go to video. Go to playlist and select the material which belongs to your level. For grade 8 and 9, look for natural sciences grade 8 or natural sciences grade 9. For grade 11 and 10, look for physical sciences grade 11 or physical sciences grade 10. For grade 12, each chapter is presented independently. Just look for the chapter of your choice and click on it. There, you'll get all the material which you need. With that, I would like to say thank you. Stay blessed. See you next time. Bye-bye.